There are two ways to analyze consequences of an explosion. The first is an analytical method, and this is the most commonly used method. This is the method that you see here. It produces some concentric circles. Perhaps in the red region might be over 1 bar, which is fatal, and in the orange region might be half a bar, or which is near fatal. Then in the next region here, it might be a lower pressure where direct death is not an immediate consequence, but if there's shrapnel, it could cause, but shrapnel could cause death. And so using this method, it's difficult to tell if the little girl sitting selling bread next to this compound is going to survive or not. The other method is CFD, and CFD is far more accurate. But the problem with CFD is that it takes a long time to do a calculation. But not this type. This is a hybrid method. Not these results that you see below here. These were produced by a hybrid method that we came up with just only a couple of years ago. And basically, the method involves the reading in of a drawing and then the calculation of the source of the explosion using an analytical method, and then propagating that out to a CFD code. This method was done in about 20 minutes or 30 minutes. There's no reason why it can't be done almost instantaneously. Here's what it needs: validation for military scenarios, faster algorithms, adaptive meshing, and then you can free yourself to do the real innovation, which is coupling to breakup models for structural components, and also adding things like machine learning for forensics. For example, in the Beirut explosion, one of the ways, one of the unknowns, the biggest unknown, is how much ammonium nitrate was ignited in the explosion. And one of the easiest ways to do that is to look at the crater. And in fact, when you look at the crater, you can easily calculate the number. It actually turned out to be 114 tons of ammonium nitrate. And the results produce an explosion that sort of matches the results that you want. So it's things like that that we need to couple with CFD in order to produce a revolutionary product.